Hello guys, in this video we are doing cubic functions. A cubic function is a function that is in the third degree, which is given in the general form f of x is equal to ax cubed plus bx squared plus cx plus d. The properties of a cubic function: it has three turning points, it has three roots or x-intercepts, it has one y-intercept. Y-intercept is a constant value d, two turning points or stationary points, one point of inflection. Its shape is a combination of concave up and concave down shapes. Let's see how it looks like. We have this coefficient of x cubed, which is a. So for positive a, the graph will look like this, and for negative a, it is like this. So this is the turning point, and the other one, the one which is said we have two turning points. Then y-intercept will be this point. Then we have the point of inflection. Point of inflection is the central point or the midpoint of the two turning points, meaning maybe it's somewhere here, or for this side it is there. Then the point where the graph is concave up, or the shape for concave up is like this, it's like a U-shaped. Then a concave down is like this. To find the roots or x-intercepts, the first step we do, we let y is equal to 0. Step number 2, you factorize the cubic function. Step number 3, solve for x. Y-intercept. To find the y-intercept, you let x is equal to 0, then solve for y. Or y is equal to the constant value of the cubic function. The constant value of a cubic function is d, so y is equal to d. E.g., f of x is equal to x cubed plus 2x squared plus 3x. There is no value of d, so we just take it as 0. So our y-intercept will be y is equal to 0, like turning point or stationary points. To find the turning point, the first thing to do is to find the first derivative of the function. Number 2, equate the first derivative to 0 and solve for x. The reason why we're equating to 0 is because at the stationary points or at turning points, the gradient is equal to 0. And after that, you substitute the x values calculated into original equation to find the y coordinates. Point of inflection. The point of inflection is the midpoint of the turning points of the graph. Also, it is the point where we have maximum gradient. To calculate the point of inflection, first step, we find the first derivative. The first derivative can be f prime of x, if it is given in functional form, or it is dy dx if it is given in graphical form. Step number 2, you find the second derivative. F prime prime of x, like this, is double. For first derivative it was 1, but for second it's 2. If it is given in graphical form, it becomes t squared y over tx squared. Step number 3, you equate the second derivative to 0 and solve for x. Step number 4, substitute the x values calculated into the original equation to find the y coordinate. Or, if you are given the turning points of the graph, you just find it's the midpoints of those turning points. Or if you are given the turning points of the graph, you simply find the midpoint of those two turning points. That will be your point of inflection. The formula for midpoint is x1 plus x2 over 2 and y1 plus y2 over 2.